Okay, now if we declare a variable locally within a function, then the content of the variable is actually garbage. Compiler never writes any implicit code to initialize such variables. Let me declare an integer variable within this function main. Say the variable var is there. Now the content of var is unknown. Now if we need to initialize the variable with some specific value, then we need to go on with explicit coding. Say I want to initialize this with 0, then I need to write it explicitly with the declaration. Now the content of var is explicitly going to be initialized with 0 immediately after the allocation. I can go ahead and initialize with any value. Now this is the decimal value. So var contains decimal 45, and we can just print the content of var using the format specifier %d. That's the format specifier for decimal integer. Here printf receives the type information as format specifier. This %d tells the printf that it needs to print the content of the variable that is passed here as the first parameter. Now everything in memory is actually represented in binary format, zeros and ones. So the content of variable var is actually in binary format. It's binary equivalent of 45 in memory. So what printf does, it converts it to the equivalent decimal and prints the content here. But if we need, we can just print the content of variable var in other formats such as octal or hexadecimal. That's also possible. There is a format specifier %o that is for octal values. That means here the printf is going to print the octal equivalent of the variable var. Now if we need to print the content of the variable in hexadecimal format, then the format specifier is %x. In this case the variable is going to be printed. In this case the content of the variable is going to be printed in hexadecimal format. Let me go ahead and run this program to show you how the formats are working. Here you can see that it's the decimal format 45, and the next line 55 is the octal equivalent of the decimal value 45, and here 2d is the hexadecimal equivalent of the decimal value 45. So we can use this format specifier %o and %x in order to get the content of a variable in octal or hexadecimal. We can initialize the content of integer variable with octal values as well as hexadecimal values. Something goes like this. Say we have a variable var1 and I want to initialize this with octal value 56. Then I can just write this. Any numeric constant starting with 0 is considered as octal constant. That means here 56 is not actually decimal 56, it's actually the octal 56. Now if I just try to print the content, let me copy these printfs. Okay, so this is var1. Now here the decimal equivalent of the octal value 056, that means 56, is going to be printed. Here it's going to be 56 because it's itself in octal format. So here the hexadecimal equivalent of the value 56, octal value 56, is going to be printed here. So let me just go ahead and run this program. Here you can see that it's 4646 is the decimal equivalent of the octal 56, and here 56 itself, because we have used the octal format specifier %o, and in the last line here you can see that it's 2e, it's the hexadecimal equivalent of the octal value 56. We can even initialize any variable with hexadecimal values. Any constant that starts with 0x is considered as hexadecimal constant. We know that hexadecimal figure A is actually equivalent of the decimal 10. So var2 contains decimal 10, that is actually the hexadecimal A. So let me just copy the printfs once more to print the content of var2. So here we go. Here first of all in this line it's going to be the decimal equivalent of A, that's 10. In this line is going to be the octal equivalent of A, and here it's going to be a itself because the variable var2 is initialized with the hexadecimal value a. So I'm running this program. Here you can see that the last 3 lines, it's 10, then 12, that's the octal equivalent of hexadecimal value a, and here is a.